Hi viewers. Today now we are going to discuss about a simple topic like that is force voltage analogy and current analogy. So to do the problems on this force voltage and force current as well as two analogies are also there, that is torque voltage and torque current analogy is also there, but I will discuss only about force voltage and force current analogy. So to do the problems, you should know this tabular column of force voltage and force current. See, if dashpot B is there. Anyway, in mechanical system, force is the input, velocity is the output. You should know this point. Force is input, velocity is output. And in electrical system, as it is a voltage. So, voltage source is the input and current is the output. So dashpot, for this dashpot f is b dx by dt we know, and in the electrical system it is given by either it is E or V. Anyway, we are representing for voltage in current analogy. We are representing voltage with E. So that's why I wrote E is equals to RA. That is V is equals to IR, Ohm's law. Next, M. For M, this we know, mechanical translational system M. F is M d square x by dt square, and here how we are writing E is equals to L di by dt, and this K is elasticity in mechanical translational system, Kx we know, and here E is equals to 1 by C integral I dt. Whenever you see K in mechanical translational system, in electrical system you should replace it with capacitor. If you see M, you replace in electrical system with inductor. If you see dashpot, you replace it with resistor in force voltage analogy, right? So now we shall see the problem, and also the force current analogy formula. See, same force current analogy. In the force, input is the force, output is the velocity, but in current analogy, input is current and output is voltage. Whatever the term here, that is the input. Here force is the input. Current is the input. If current is input, obviously we know voltage will be the output. But in mechanical system, output will be the velocity. See, in force current analogy, for dashpot, it is resistor. For mass, you should replace it with capacitor. And I think we all know this formulas already we studied. I is equals to C dV by dt, and I is equals to 1 by L integral V dt. So for K, you replace it with inductor. I is equals to 1 by L integral V dt. So you should remember these formulas, force voltage and force current. With that knowledge, we will do one problem. Okay. So see, this is the problem given with force voltage analysis. This is the free diagram given. So now you should write the free body diagram for this problem. So anyway, only given one M, K and B dashpot. So force is there. So F is equals to, F of t is equals to Fm plus Fb plus Fk, right? So you write the formulas. Fm means m into d square x by dt square, b into dx by dt, and k into x. If you write x of t, no problem. X of t you can write, dx by dt also you can write. But when you are taking the Laplace transform, it changes is to f of s is equals to m into s square into f x of s plus b into s into x of s plus k into x of s. So up to here, as usual as mechanical translational system. Now comes the force voltage analogy. So what we studied in force voltage analogy, we should replace dashpot with a resistor. So one dashpot is there. You replace dashpot with a resistor, and K with capacitor, and M with a inductor. So in force voltage, all these are in, see what here the connection is like series connection, all are in straight line. So you connect it in a series connection. And what the input is here? Force. So force voltage means input is voltage and output is current. So for this now this is the electrical network for this translational system, right? Here whatever the connection is there, in that manner you should connect. Here all are in series. So for force voltage, you should connect same manner what is here. Resistor, inductor and capacitor, but not correspondingly I drawn here. See, for K I should draw capacitor starting, and then M inductor, and then resistor I should draw, but nothing happens as they are series. Okay, so inside it is current. So apply KVL. You write the equation V is equals to IR. Ri plus inductor in terms of I is L di of t by dt and 1 by C integral I of t dt. Now see, this you should remember. In force voltage analogy, this is the main thing you should remember. Current based on charge I of t is equals to dq by dt. This is equals to q of t is equals to what becomes here differentiation, this term goes into a integration. So it becomes integral I of t dt. Differentiation, if it goes this side it becomes integration, and integration if you send this side it becomes a differentiation. This, with this knowledge, I of t equals dq by dt. Now we substitute this here. So V of t is equals to R into dq of t by dt plus L into, see what is I of t, dq by dt, and another d by dt is there, one d by dt into dq of t by dt. So it becomes d square q of t by dt square plus 1 by c. See what is integral? Integral I of t dt means q of t. Okay. So taking the Laplace transform, V of s is equals to Rs into q of s, Ls square into q of s, okay, plus 1 by c into q of x. So you are going to get Vc of s. So compare this equation with this equation. See, s square what is there? M. I wrote both the equations here. What equation here you got? M s square f x of s plus bs x of s plus k into x of s. And this equation what I got? V of s is equals to L s square q of s plus rs q of s plus 1 by c into q of s. See, when we compare what we got, M with L, B with R and K with 1 by C. See, the same what we wrote in the analogy, force voltage analogy, what we wrote, B with R. So same I got, B with R, and M with inductor, M with inductor L, and K with capacitor 1 by C. The formula we wrote it as 1 by C integral I of t dt, right? Next, force current. See, remember, force voltage and force analogy will be reversed, right? Now I wrote here series connection, right? So for this same problem, force voltage is this. So for this only now we are going to write the force current. Then how it will be? If they are series in force voltage, they will be parallel in, see, they will be parallel in force current analogy. And the equation is same equation, right? This for same problem we are writing, no, f of s is same, right? Now they will become parallel. So see, apply the KVL, as this is a force current. So current will be the input and voltage will be the output, force current. So you should write in terms of I equals to, so all currents should be added, and you should write I of t is equals to, so IR means what we know, V of t by R, and L in terms of I is equals to 1 by L integral V of t dt, and C in terms of current in terms of C capacitor and voltage is C dV by dt. And this force current analogy you should remember this formula, right? V is equals to flux d phi by dt, and phi of t is equals to, this side it goes, it becomes integral V dt, right? So right, substituting in this equation, same previously what we did, 1 by R into V is d phi, here V of t is there, no, that's why again I wrote here integral V of t into dt, V dt or V of t dt, no problem. So 1 by R into d phi of t by dt. Why? V is nothing but d phi by dt. So in place of V, you write d phi of t by dt plus 1 by L. Integral V of t means phi of t plus C into d by dt into d phi by dt means it becomes d square phi of t by dt square. So now taking the Laplace transform on both sides, I of s is equals to 1 by r into s into phi of s. If d by dt of means 1 s will be there, square means s square term will come. Okay. So 1 by L into phi of s plus c s square into phi of s. You write s square s and then without s term. So compare this equation with this equation. See this equation and this equation. So what we got for m, c, b 1 by r and k is 1 by L. See the force current analogy formulas. Force current analogy, B should be 1 by R. We got no? B is 1 by R. And see M. M is C. M is replaced with capacitor. And K is replaced with inductor. 1 by L integral V dt. No? So that's why we got 1 by L. So remember one thing. Force voltage while writing for this analogy, whatever this is, the same format you write here. If you write force voltage, then you can easily write the force current, which is the reverse of this force voltage. Series becomes parallel in force current and parallel becomes series for force current, right? So this we drawn from this table. So we drawn how we substituted in K, M, B means we gathered the information from this tabular column. So everyone should remember this tabular column for force voltage and this tabular column for force current analogy. Thank you.